Let us see as to what is the agenda for today's meeting now. See, we are going to discuss about a course developed by us called as Cyber Security with Palo Alto Firewall. We are going to see as to what is the syllabus covered in this particular course and why that particular syllabus is designed like that. What is the training methodology? What about the lab practice? We do activity-based training. We'll see as to how the lab practice would be. We also discuss about the recorded sessions. So most of students would like to recap after the class is over. So we'll also discuss about the recorded sessions. We'll also see quiz and self-assessment test. Right? Once you learn some concept, there should also be some quiz so that you can understand the concepts better. And you'll also discuss about the trainer. Right? Now let us see the introduction to the course now. Syllabus covered. We divided this particular syllabus into some units like this. Unit 1, Unit 2, Unit 3, 4, 5, and then 6, and then what? 7. We start with the routing and switching concepts on the Palo Alto firewall. Any firewall for that matter is also acting as a router. What do you mean by acting as a router? Whenever any packet comes to any device, the device opens the first cover, they open the second cover, they see the third cover. If the IP protocol on the device is acting as a router, means IP forwarding is enabled on the IP protocol on the device. What does it mean? If at all any packet comes to you, where the two IP address is not your own IP address, don't drop the packet but forward the packet. So routers do what? Forwarding. Router is a function, not the device. A firewall also can act as a router. Windows system also can act as a router. Linux system also can act as a router. A load balancer can also act as a router. A router also can act as a router, right? So router is what? Not a device. It is a function. Means whenever any packet comes to you, when the two IP address in the packet cover is not your own IP address, don't drop the packet but forward the packet. If IP protocol on the device is configured to forward the packet, then the device will be acting as what? A router. Right? So firewall also, a Palo Alto firewall also acts as a router. Right? Now on the Palo Alto firewall, the Ethernet interfaces are not defined as either layer 2 or layer 3 interfaces. So you need to go and inform sender this interface is layer 2 type of interface or layer 3 type of interface. If you define the Ethernet interface as layer 2 type of interface, then it starts acting as what? A switch interface. So the firewall also has got a switching fabric. So it considers as though the packet is, the port is connected to a switch. So now you can keep that particular interface in a VLAN or layer 2 security zone. And then as a firewall, when the packets are coming via this interface, also check for security. If you define an interface as a layer 3 interface, then you are defining that interface as what? A router interface, and then you can assign it to a virtual router. If you define the interface as layer 2 interface, then you can assign it to what? A VLAN. If you define the interface as layer 3 interface, then you can assign it to what? A virtual router. As any regular switch does address learning, the switch on the Palo Alto firewall also does what? Address learning functionality. Means by learning which particular system is connected to which particular port, the Palo Alto firewall switch does not flood the unicast packets unnecessarily. You understand now? So as how you can see the MAC address table on a Cisco switch, you can also see the MAC address table on the Palo Alto firewall. So, and then the packet has to go through the firewall. Only if you learn how to make any packet come through the firewall, enter the firewall through one particular port and make it go through some other port, only then you can learn how to give security for those packets, for those communication, right? So whenever you start any class on any firewall for that matter, you should start with what? Understanding the routing and switching concepts on the Palo Alto firewall. On the Palo Alto firewall, you can configure different types of interfaces like Ethernet interfaces, layer 2 or layer 3, Ethernet layer 2 sub interfaces, Ethernet layer 3 sub interfaces, right? Tunnel interfaces, loopback interfaces, VLAN interfaces, right? You should understand what context these interfaces are created on the firewall or configured on the firewall, and then learn the routing and switching concepts first of all on the firewall. Only when you can make the packet go through the firewall, you can ask the firewall to do security, right? So we added all those concepts in a unit called as routing and switching concepts on Palo Alto firewall. Once you understand this, we'll go for understanding how to configure security policies on the firewall and also network address translation on the Palo Alto firewall. Then we learn how to configure site-to-site VPN, how to configure remote access VPN, and then URL filtering. Then next generation firewall features like checking firewall, checking for spyware, malware and all, and also miscellaneous topics, right? So we divided our syllabus into 7 different units like this, right? Now I'll walk you through all the units and also walk you through the case study diagrams and understand also as to what concepts are taught in this particular unit, right? In unit number 1, first of all, we learn as to how to configure the management interface on the Palo Alto firewall. We'll also learn about virtual routers on the firewall. We can create more than one virtual routers on the Palo Alto firewall, right? We see how to see the routing table, which part routes will be there by default in the routing table of any virtual router. We learn as to how to configure static routing on the firewall. Means how to do static routing between the virtual routers on the Palo Alto firewall. Means how to configure dynamic routing using RIP protocol, OSPF, BGP. BGP again we see as how to configure IBGP and EBGP routing protocols. And then we also see how to configure redistribution profiles so that you can redistribute the routes from connected, static, RIP protocol, OSPF, BGP into another routing protocol. How can you ask the other routing protocols to redistribute some other source routes? We see all these concepts in using different case studies in the first unit. As we learn all this, we also learn as how to configure layer 3 security zones and also layer 2 security zones. Until and unless an interface is in some zone, the packets coming via this interface are not processed for security on Palo Alto firewall. So we need to keep the interfaces in certain zones. Any zone. The zone type could be either layer 2 or layer 3 or trap or V1. It could be different type of zone, but it should be belonging to some security zone before it could be processed for security. The packets coming via this interface are processed for security. And interfaces are we see about Ethernet interfaces, layer 2 interfaces, layer 2 sub interfaces, layer 3 interfaces, layer 3 sub interfaces, and also VLAN interfaces, loopback interfaces, right? And also let's say tunnel interfaces. We'll see how to configure all these different types of interfaces in their particular context. We create situation where these interfaces are required to be configured and then learn the concepts about the interfaces. We also see how to check the MAC address table, how to verify the routing table, MAC address table, right? Also how to configure inter-VLAN routing on the Palo Alto firewall. As a one Cisco router, you can create sub-interfaces. We call it as what? Router on the stick configuration, right? You can also do the same thing on the Palo Alto firewall. We also can configure interval and routing on a layer 3 switch by configuring SVI, switch virtual interface. Same thing we can also do on the Palo Alto firewall by creating something called as VLAN interfaces. So what we do is, we create situations where these type of interfaces are required. We create situations where layer 2 sub interfaces are required. We require this when the packets are coming from Cisco environment to Palo Alto environment. See, we know that VLANs are nothing but broadcast domains, right? And VLANs are not according to the principles of networking. If you go to any system and say which part of VLAN you belong to, the system may say what is VLAN in the first place. VLANs are not according to principles of networking. They are because of some intelligence given to the switches, right? So VLANs can be identified. The broadcast domains could be identified by a number or a name, right? On Cisco routers, the VLANs are identified by a number, whereas on a Palo Alto firewall, the VLANs are identified by a name. So if at all via trunk link, the packets are coming to the Palo Alto switch, they come as what? A number. If they're coming from Cisco environment, the VLAN tag will be what? A number. But in the Palo Alto environment, you should map it to a name, right? So how do you map a VLAN ID from Cisco into the Palo Alto? By creating what? Layer 2 sub interfaces, right? VLAN interfaces are nothing but like SVI in Cisco switches. Loopback, when you want, let's say, two different, the BGP routing protocol, if you want to configure dynamic routing between the virtual routers running on the firewall, the better option would be what? Configure BGP routing protocol between the virtual routers running within the firewall. So then you need to create some what? Loopback interfaces. One condition, one context where you could create the loopback interfaces. We also create tunnel interfaces. If at all you want to create GRE tunnels, or you want to tell the firewall, when the packets are going for so and so area, add one more IP cover. And the IP cover should have public IP addresses so that the packet could be routed on the public network. We create something called as tunnel interfaces. We also create tunnel interfaces when you want to configure IPsec VPN between two different private network IDs, right? So you'll see that. And also how to HA interfaces. You want to use high availability, active, passive. We create something called a high availability interfaces so that they can also exchange the stateful tables with each other, right? Like that we have some concepts. So when you learn about these interfaces, we understand as we want context, in what context these particular interfaces are required. In that context, we configure these interfaces and then learn about all these concepts, right? So what you do now, in the first chapter, unit, we learn about how to configure, we learn about the routing and switching concepts on the firewall. For example, any firewall in the world, when you learn about, say, ASF firewall, or like say even checkpoint firewall, any firewall, 48 firewall, you need to learn first of all what? You should start with what? Routing and switching concepts on the Palo Alto firewall. Only if you can make the packet come through the firewall, go through the firewall to other places. If you can make it go the way you like, then you can add one more layer saying that this part check for this, check also this, check also this, check also this, and ultimately deny or allow the packet access, right? So first you should understand what? How to make the packet go through the firewall, right? The way you like. So I thought I'll add this in the unit number 1. Now let us see what case studies are there in unit number 1. We also learn about interface management profile. You can't ping to the firewall. And if at all you want access to certain services on the firewall, the traffic interfaces, then you create a profile saying allow this, and that has a profile to the interface. So you also learn all that in this particular chapter. Right? So we learn how to configure the management interface, how to configure interface management profile, we also learn how to configure the routing concepts on the Palo Alto firewall. We learn about the switching concepts on the Palo Alto firewall, right? As we learn all these, we also learn about how to configure different types of security zones on the Palo Alto firewall. We also learn as to how to verify the routing tables, also how to verify the MAC address table and all. Now let us have a look at the case studies we'll be working with to understand about the Palo Alto. So this could be our first case study. In this case study, what is simple case study where we have two different network IDs, 192.168.1.0 network ID and 192.168.2.0 network ID. When these different systems in different network IDs want to talk to each other, we need a router in between, right? Only a router could forward the packets from one TCP/IP area to some other TCP/IP area. So I would like to configure the virtual router on the Palo Alto firewall. There's only one box. There's only one firewall box. In the same box, we have, let's say, a router as well as the security card, right? So I would like to configure the router running on the firewall to forward the packets from one area to other area. In other words, we are trying to learn how to configure the virtual routers to do IP forwarding on the Palo Alto firewall. As we learn this, we also learn how to configure the management interface. How to configure the management interface. Somebody is trying to annotate. No, please not. Thanks. So how to configure the management interface on the Palo Alto firewall. How to configure and how to log on to the firewall using the browser on this particular system using HTTPS connection, and then how to actually first of all change the password, username and password on the Palo Alto firewall, right? Username is admin. How to change the password on the Palo Alto firewall, the default password. Once you log on, how to name the firewall, how to change the time zone on the firewall, how to configure virtual router on the firewall, how to configure layer 3 security zones on the firewall, how to configure interfaces on the firewall, how to commit the changes on the firewall, how to verify the routing table on the firewall, what security policies are there by default on the firewall for interzone and intrazone traffic. And then because packets are going from one zone to other zone, this comes under what? Interzone traffic. And how to allow the packets to go from one area to other area on the firewall. So we can check all this. So this particular case study is only to make you understand how to configure the basic configuration on the Palo Alto firewall, right? Next we go for second case study where we learn how to configure static routing on the Palo Alto firewall. This is one firewall box, this is another firewall box. And if you say carefully, this virtual router knows only routes for these two areas. It doesn't know routes for 3.0 area. And similarly, this particular router knows routes for these two connected areas. It doesn't know route for this area. So we tell the virtual router here, if at all the packet has to go to this area, send the packet so-and-so next stop router. Again, we tell the router, for this area, pass on to so-and-so next stop router, right? So how to do static routing between two different Palo Alto firewalls, we learn in this particular case. As we do this, we'll get more practice on working with the firewall, how to configure the management interface, how to log on to the firewall, how to change the name on the firewalls, how to configure virtual routers on the firewall, how to configure the security zones on the firewall, how to configure interfaces on the firewall, how to modify security policies on the firewall, how to do static routing on the firewall. As you do all this, you get more familiar with working with the firewall. So that would be the objective of our second case study. Then in the third case study, what we do, we see how to configure virtual routing between the virtual routers and firewall. There's only one box. There's only one firewall box. We configure one virtual router here. We also configure VR2 virtual router, and this will know only routes for this area. This will know routes only for this area. So when the packet comes to the router for this area, the route is not there. We say for so and so area, pass on the packet next to hop router, next to VR, virtual router, right? So how to configure static routing between the virtual routers running on the same firewall, right? We'll be learning this particular concept also. Then we'll understand as to how to assign the interfaces to different virtual routers. This interface should be assigned to VR1, this is to what? VR2, right? We learn all these concepts. As we do labs like this, we get more familiar with configuring the Palo Alto firewall. Then we would like to go for this case study where we do static routing, a bigger case study to understand the concepts better. I kept here two Cisco routers, one Cisco router here, one more Cisco router here, and this is what? Palo Alto firewall virtual router, Palo Alto firewall virtual router, right? So, how to do static routing? If you see carefully, this will not only routes for this area and this area because these two are what? Directly connected. For all other areas, 3.0, 4.0, 5.0, 6.0, 7.0, we say pass on the packet so and so next top router, right? Same thing we also do on this particular router. This only knows for this connected network IDs only. Doesn't know routes for all other areas. We say pass on the packet so and so next top router, right? Similarly, the Palo Alto firewall router also knows routes for what? This, and this because all these three are what? Directly connected. We had a route saying what? For this area, pass on to so and so router. For all other areas, pass on to this particular router, right? We see how to configure static routing on the Palo Alto firewall with more areas and more routers. Then, on the same case study, we work with what? How to configure RIP protocol, RIP, Routing Information Protocol on the Palo Alto firewall. As we do it, we also learn how to redistribute the routes. Say for example, on Mango or when I configure RIP protocol, I configure RIP on the router as a whole, and then I configure on this interface, right? Only if I configure on the interface, it starts sending the updates or receiving the updates via this interface, right? But why should I enable on this interface? This interface is connected to what? A switch here, some systems are there. There's no router here. If there's no router here, why should I unnecessarily enable RIP protocol on this interface and keep on seeing the updates every 30 seconds? Not required, right? I'll be flooding this particular network unnecessarily with the RIP protocol updates. So I don't want to enable on this interface. But if I don't enable on this interface, this particular network ID should also be known to other routers. How do you ensure that? I redistribute the routes. I ask the RIP protocol to redistribute the connected routes into what? RIP protocol. Same way here also, when I enable RIP protocol on the router here, Palo Alto firewall, I would like to enable it only on this interface and only on this interface. I don't want it to enable on this interface at all. Why? Because there's no router here. There's no router here, why should I enable RIP unnecessarily here again, right? So but I want the 3.0 network ID to be known to all the routers. How do I do that? I ask RIP protocol running on the router to redistribute the connector routes into our RIP protocol. For that I create something called as redistribution profile on the Palo Alto firewall. When I do redistribution, I can also apply a filter. So and so routes alone should be redistributed into RIP protocol. We also have to apply a filter and then redistribute the connector routes into the RIP protocol. Right? Same thing we do on this particular firewall here. Same thing we do on the router here, and ultimately make sure that all the systems can talk to each other, right? So the objective of this particular case study would be to configure RIP protocol on Palo Alto firewall and also configure redistribution profiles on the firewall and ask the RIP protocol to redistribute the routes according to so and so profile. Actually, I uploaded one video about this particular case study in the YouTube channel. You can go to YouTube, search for our, let's say, channel Koti Concepts. We have a channel called as Koti Concepts. I started this long time back, but I was not very active in this particular channel. I never bothered. But yesterday I uploaded a video about the case study solution of this particular protocol only. You want, you can watch. Then the next case study would be to configure OSPF on the Palo Alto firewall. See carefully here. Again, same case study only, but I thought I'll configure what OSPF. How to configure OSPF protocol on the Palo Alto firewall. Configure only on this interface only. Configure area first of all. Keep the interface in so and so area. How to assign router ID, right? Again, I don't want enable on this interface, but I want this network ID to be known to other routers. How to configure redistribution of the connected routes into OSPF, right? As how we did for RIP protocol. Same thing we would like to do for OSPF. Again, also learn the commands you give on the protocol to verify the OSPF neighbors. On the Cisco, we give the command show IP OSPF neighbors, right? Show IP OSPF interface, so on so, right? Show IP was database, right? Similarly, there should be some commands on the Palo Alto file also. Show routing protocol, OSPF, neighbors, right? LSDB. Like that, we try to see the commands on the Palo Alto firewall to verify the OSPF, adjacencies, neighbors, and all the concepts, right? Database and all that. It's a good case study on how to OSPF on the routers. Then we thought we'll have one more case study on how to configure BGP routing protocol on the Palo Alto firewall. Right? If you see here, this is one ISP here. Imagine AS100, one more ISP AS400, one more ISP here AS200, one more ISP AS300. Configure eBGP routing protocol. eBGP routing protocol. And also eBGP routing protocol, right? How to configure BGP routing protocol on the virtual routers running on the firewall, and also configure redistribution of the connector routes into BGP, right? So on Cisco, we have the network command. To address this called the network ID into BGP, you can say network command. Network command is not there in Palo Alto firewall. We'll see all this. And we see the BGP table of the routers, right? When they learn the route in the BGP table, they also, when the best path algorithm is run on this, and the best path is given to the router automatically, right? On the Palo Alto firewall, only when it's installed the route will be suggested to the router. We'll see how to see the BGP table on the Palo Alto firewall, how to see the BGP neighbors on the Palo Alto firewall, also how to redistribute the routes, connect routes into BGP. All these concepts we learn under this particular case study. Then we develop one more case study where you learn about how to configure IBGP. You see this case study here. Here we have what? Here we have, let's say, AS100, AS300. This is what? AS200. And if you see carefully, it's only one box. It's only one firewall box in which we have two virtual routers. Two virtual routers running on the same firewall. Palo Alto firewall, right? So when this particular router here learns the routes from this particular eBGP, we should pass on to this particular router by IBGP connection. This is what IBGP, right? Again, when learn IBGP, send to what? Again, eBGP to this particular neighbor, right? So how to configure IBGP between the virtual routers? There's no IP address here, no IP address here, right? These are virtual interfaces. So what we do now? We configure a loopback interface on VR1, another loopback interface on VR2, and configure the BGP routing protocol between the loopback interfaces, between VR1 and VR2 virtual routers, right? How to do that? We have to start, first of all, you should take care of reachability by configuring static route for so-and-so IP, so-and-so mask, send to next stop virtual router. We should do static routing. We also need to configure the policy because packets are going from what? Zone 3 to zone 6, right? Different zones, right? Inter-zone traffic. The security guard will not allow the packet to go. Allow the reach with the security policy, modify the security policy. And then also let's update source loopback interface, right? The command is a Cisco router. So when the updates are being sent, use this particular IP address to send the updates. Only when you take care of, they become what? PS. And when you learn from eBGP, I don't mind giving to IBGP neighbor, but I don't change the next stop attribute to myself. So until as you say that, right? So we need to solve all this so that the routes can be learned from R1 router given to VR2, packet can go in, right? So they can route the packets properly. So it's a very good case study on how to configure BGP routing protocol between the virtual routers running on the same firewall, right? We'll do this further case study. Then we thought, why don't we add a combined case study so that you learn all these concepts in combination. If you see carefully here you see here between these two routers also what? Static routing. Between these two routers also what? Static routing. In these two routers what? READ protocol. Between these two what? OSPF. But again between these two what? READ protocol. Between these two what? OSPF. In this two again what? BGP, right? So we configure static routing, READ protocol, OSPF, BGP, all at one go on the virtual router and same firewall. If you see here, there is only one firewall box. The same firewall box you have say what? VR1 virtual router, VR2 virtual router. Between that we are trying to do what routing, right? So once you do that, you know how to verify the OSPF neighbors, BGP neighbors, how to learn these routes, right? Then what are redistribution now? You should send the connected route, this called a connected route, and this called a static route into READ protocol, into OSPF, into BGP. Again, READ routes into OSPF, READ routes into BGP, OSPF into READ protocol, OSPF into BGP, BGP into READ protocol, BGP into OSPF. Again, on this router, all the routes will come as what? BGP routes, BGP into READ protocol, BGP into OSPF. Again, connected into BGP, connected static into BGP, RIP into BGP, OSPF into BGP, right? RIP into OSPF, OSPF into RIP protocol. Now, so maybe default route here, right? So at one go, you learn all the concepts. As you do the configure routing protocols, also configure redistribution, you learn how to configure the dynamic routing protocols, routing concepts on Palo Alto firewall. This is a combined case study. This is like question number 9, unit number 1. Then we try to learn about the switching concepts on the Palo Alto firewall. If at all I define these interfaces as layer 2 interfaces, once you define these interfaces as layer 2 interfaces, what happens is, so they can attach it to what? VLANs. How to configure VLANs on the Palo Alto firewall. See, all these three components are there on the same firewall box only. The virtual router on the firewall, the switch on the firewall, and security guard, security module on the firewall. All three on the same box only, right? So once you configure these interfaces as layer 2 interfaces, right? And again, this is what? VLAN. So what happens now? This is what? Zone 1, zone 1, zone 1, zone. So you all can talk to each other, right? Intra-zone traffic, no need for any security policy. But you can check the MAC address table of the switch. There's a command, show MAC all. It shows which folder system is behind which folder interface, right? Again, if you see here, these are in what? Zone 2. These two are in what? Zone 3. Even though they will say VLAN 20, VLAN 20, 20, 20, they should talk to each other. But again, inter-zone traffic, right? So between the zone 2, layer 2 zones, how to go security policy so they all can talk to each other, right? And if at all I want to make again these systems talk to these particular systems, we need inter-VLAN routing. That will do on what? By getting VLAN interface on the virtual router running on the firewall, right? It's a good case where you learn how to configure layer 2 interfaces, how to configure the VLANs, how to configure the virtual router with VLAN interfaces, and ultimately how to configure inter-VLAN routing by the Palo Alto firewall virtual router, right? So this will be the switching concept, first case. Then we go for this particular case study where we learn about how to configure layer 2 sub-interfaces. How to configure layer 2 sub-interfaces on the firewall switch. See here now, on the Cisco environment, here we have, let's say, VLAN 10, VLAN 20, And this is configured as what? Trunk link, right? So when the packets are sent by this folder switch, when the system sends any broadcast packet here, the broadcast will be sent by the trunk link also. The VLAN tag is what? 10. The broadcast comes like this, the VLAN tag will be what? 20. On the Cisco environment, the VLANs are identified by a number. Whereas on the Palo Alto environment, the VLANs are identified by a name. I want to identify VLAN 10 as what? A. VLAN 20 as what? B. So how do I map that? So I tell the switch here, the Palo Alto firewall switch, when the packets are coming via this particular link with the tag as 10, receive the packets via Ethernet 1/1.1 subinterface. You understand, no? And that interface belongs to what? A zone called as zone 1, layer 2 zone called as zone 1. And also the VLAN ID of that interface for VLAN 8. So that's how we map the Cisco VLANs to the Palo Alto VLAN. And then do inter-VLAN routing again by this folder router. It's a very good case study where you learn how to configure layer 2 sub-interfaces on the Palo Alto firewall. We are learning about how to configure interfaces in their context. What's the need to configure like this? Because Cisco environment they are numbered, whereas Palo Alto they are named. Somewhere we need to map and also make sure that they are received via one interface so that they belong to what? Different security zones. So you can apply security policy on this folder packets. Then we go for another case study here where we learn how to configure the layer 3 sub-interfaces. Layer 3 sub-interface. Here all these three are Cisco switches and they are directly connected to what? The Palo Alto firewall router. So when the tag is 10, right? Tag will be 20 here. Received by whom? Ethernet 1/1 sub-interface, 1/2 sub-interface. So you can apply security policy on this particular packet and also do what? Inter-VLAN routing by the virtual router. So like that we learn these three case study switching concepts on Palo Alto firewall. Then as how we normally do, we also have a combined case study. Combined case, we learn all this concept one go. See carefully here. This is only one box. This is only one box. Only one firewall box. In which there are, let's say, two virtual routers. VR1 virtual router, VR2 virtual router. And they also have a switch. And also firewall module, security guard. Right? All the four components, same firewall box. Because we configure these interfaces are layer 2 interfaces, we keep them in some VLAN. They attach to what? The switch. And here Cisco environment is there. Cisco switch is talking to the Palo Alto firewall switch. So different VLANs should be mapped to the VLANs on the Palo Alto, right? We said they are named here, they are numbered here. So to configure Ethernet layer 2 sub interfaces. Layer 2 sub interfaces, right? And for all these VLANs here, inter-VLAN routing is done by this particular virtual router number 1. And here again you have Cisco environment here, switch is connected to what? The Palo Alto firewall. Again inter-VLAN routing is done for this particular networks by what? This particular VR2 by configuring layer 3 sub interfaces. But again what should I do? To reach all these network IDs, we should tell the virtual router send the packet so and so router. To reach all these network IDs, we should tell the router send to so and so virtual router, right? We should do again what? Static routing between the virtual router so that all the systems could talk to each other. And ultimately ask the security guard, don't worry about any security right now. For all the zones to all the zones, allow all the packets to go so that we can ping and check whether we are able to reach the systems. It's a combined case study on learning all the switching concepts on the Palo Alto firewall. Right? So far you understood how to configure Ethernet layer 2 interfaces, Ethernet layer 2 sub interfaces, Ethernet layer 3 interfaces, layer 3 sub interfaces, VLAN interfaces, and then the loopback interfaces, right? And also how to configure static routing, dynamic routing using RIP protocol, OSP or BGP on the Palo Alto firewall, and also how to configure the routing between virtual routers on the Palo Alto firewall. and also how to verify the routing table, verify the MAC address table on the phone. Now we learn about how to configure the GRE tunnel interfaces. Tunnel interfaces. When the packets are going to the branch office net, you want to make two different private network IDs, talk to each other through the public network ID. We create something called as what? Tunnel, right? What do you mean by tunnel? The packets are leaving us so tunnel means what? Add one more IP cover. The new IP cover add your own address as source IP, two address as what? Branch office firewall's IP address, right? We learn first of all about what is meant by GRE tunnels and then create site-to-site VPN using GRE tunnels. In that context, we create what? Tunnel interfaces on the firewall, right? We learn this one head office and one branch office. Then we take one more case study where we have one head office and two branch offices. We have one head office here and two different branch offices. Head office here, branch office 1 and branch office 2. So one tunnel for head office to branch office 1, one more head office to branch office 2, again BO1 to BO again one more tunnel, right? So fully missed topol when you configure is how to do that using the tunnel interface, GRE tunnels, right? That's the 15th case study. Then we go for configuring same thing only, but hub and spoke topology. So we don't want the B1, BO directly talk to each other. Want the packet to come to head office and then go like this. So we configure something called as only one tunnel, right? It's basically the same thing only. The routing should be done in such a way that the packet goes to head office before going to the branch office. Then the same case study, we learn with what routing protocols on the tunnel interfaces. Here you have a READ protocol here. Here you have a OSP routing protocol between the firewall and the layer 3 switch. Between the firewall and the layer 3 switch, here we have what? RIP protocol, right? But here again we have what? Static routing. And on the tunnel we have what? BGP routing protocol. BGP routing protocol, right? How to call BGP routing protocol on the tunnel interfaces, right? And redistribute the routes from RIP into BGP, static into BGP, OSPF into BGP, so that all the systems could talk to each other, right? So those things and all we'll do here in this particular case study. So this case study number 17, we'll learn how to configure GRE tunnels and also dynamic routing protocols on the GRE tunnels on the Palo Alto firewall. So a good case study to understand this particular concept. Then we go for this case, we learn about policy-based forwarding. See here, you have say only one box. Same box, your one firewall module is there. You have say two routers are there. This route connected what? First ISP1 and ISP2, right? So the packet has to go like what? Packets are coming from here. They should go to whom now? First router, first ISP. Link goes down. First router, second ISP. Link goes down. Packet has to go second router, first ISP. Link goes down. Packet has to go second router, second ISP, right? So how do you configure the routers here with static routes, path monitoring, right? We do all this on what? Using tracking, IPSLA on Cisco routers, right? Same thing we try to do on the Palo Alto firewall. But this network, I want the packet to go like this first of all. I don't want it to go through the routing algorithm. Policy-based forwarding, PBF, on policy-based routing on Cisco routers, right? So those concepts we learn under this particular case study. Once you understand this case study, we'll see how to configure multiple ISPs, ISP1 R1, ISP2 here. Again, the packet has to go like this to the head of branch or link goes down. Packet has to go like this, right? So there should be two tunnel interfaces now. How to configure network address translation and GRE tunnels with multiple ISP redundancy. The good case study to learn all this. Here we learn so many concepts, how to do static routing, how to do path monitoring. So many things go together to get this particular effect. As the links go down, this particular link goes down, packet has to go like this first of all. Link goes down, then packet has to go like this. So NAT should also work properly, GRE should also work properly, static floating routes, right? So many concepts go together in giving this particular packet. Case study number 19. Then we go for case number 20 where you learn about high availability, HA interfaces. The head office firewall here, head office firewall too. Packet has to go to first firewall. Firewall goes down, packet has to go second firewall, right? So high availability, we will learn in this particular case study. And then I will also learn about how to configure DHCP route protocol on the Palo Alto, how to make a DHCP relay agent, those concepts, right? So like we configured around 21 case studies in the first unit, right? We learn everything about what? Routing and switching concepts on the Palo Alto firewall. Only if you can make the packet go through the firewall, through different interfaces, in different contexts, the way you like, then you can ask the firewall, check also for virus, check also the user ID, check also the content, check also for application, and then you can give more secret, right? If you don't know how to allow the packet go through the firewall, what's the point in learning all that? So we all, in all these case studies here, we only tell the firewall, allow any packet to go, don't worry about security. You're only worried about what? Learning the foundation on the Palo Alto firewall. So objective of unit number 1 would be to first of all configure different types of interfaces in their context, right? And also allow the packet to go the way you like. Once you do that, now we are in a position to understand how to configure the security policies on the Palo Alto firewall. So next case study would be, next unit would be how to configure security policies and network address translation on the Palo Alto firewall. So now see, DNS concepts, network address translation and the security policies, they go hand in hand. When the systems in the office want to talk to the internet, NAT is required. And you always go by what? The name, right? We don't know the IP address, you give what? Name in the command. Whenever you give the name has to get resolved IP address. So DNS concepts, network address translation and the security policy, they go hand in hand. So we developed a case study where we learn all this. Under DNS, we see how to configure DNS recursion process. We have root DNS server, top level domain servers, what domain delegation, conditional forwarding, DNS forward rewrite, DNS reverse rewrite, DNS MX records, caption the DNS standard query request, how the packet looks like, response packets. So once you understand DNS thoroughly, then only you can also understand how to configure source NAT, destination NAT, how to configure dynamic NAT, dynamic source NAT where translate the source address to interface IP address, a pool of IP addresses, static NAT, U-turn NAT, DNS forward rewrite, DNS reverse rewrite, session distribution, load balancing using NAT, twice NAT, static DNS destination NAT, and how to call security policies keeping in mind the network traffic pattern and then the packet structures. You understand? No? You also need to understand the packet flow. What happens first? NAT happens first and then checking happens. You should write the rules for what? The NATed IP addresses. If checking happens first and then NAT happens next, you should write the rules for what? This is a pre-NAT interface. So those things should all be understanding in a case study diagram. We have only say 13 different tasks are there. 13 different, let's say, case studies are there where you need to do all this. So if at all I connect to real internet and then try to show this, we can't do this lab because we don't have control over the public IP addresses. We don't have control over the root DNS servers, top level DNS servers and all, right? So what we do, we prepare our own lab internet. We work on a case study like this where this is our lab internet. This is our lab internet. We have our own ISP DNS server, our own root DNS server, our own COM DNS server, our own, let's say, IBM servers and all. I put some company here. And also the Cisco web server, FTP server, mail server, right? Internet clients with all what? Public IP addresses. So ISP routers. We have control over everything so that we can learn all the NAT concepts properly in our case. And this is our head office. This is our network. We are, let's say, here we have head office. Mango head office here, Mango DMZ1 here, DMZ2 here. In the DMZ are say what? DNS server, HTTP server, FTP server, mail server. Again HTTP servers here, FTP servers here, right? We keep lot of servers here, and also the mail server. And also here we have say different VLANs, VLAN 10, 20, 30, 40, different network IDs are there here. And when these guys want to access internet, we do what? NAT. How to configure NAT, right? How to configure DNS server, how to configure security policies. So DNS, security policy and NAT, they go, all the three go hand in hand in understand how to configure the firewall with all these further features, right? So a good case study we have, let's say, see lot of combination. We see how to do decision. When these guys want access www.ibm.com, the packet goes to internal DNS server. We enable conditional forwarding, goes to ISP DNS server. Only caching only DNS server, talks to root DNS server, gets the address of COM, talks to COM, gets the address of IBM, talks to IBM DNS server, gets the address of IBM, then only gives to this particular client, and then this will go, right? So how to configure security policies to allow to go through the firewall, how to go network address translation, all these things will be seen in this particular case, right? Like that, so many concepts, around 13 different concepts I added in this to learn about the security policies. Then we see how to configure site-to-site VPN on the Palo Alto firewall to secure the TCP/IP communication, right? So what securities are required? We need confidentiality, integrity, authentication, accountability, right? For you understand the basics of cryptography, what's key, algorithm, public key, private key, certificate authority, message digest, symmetric encryption, asymmetric encryption, right? About IPsec protocols again, or encapsulated. So only when you understand all these concepts, you can understand how to configure the site-to-site VPN on the Palo Alto firewall. You understand, no? So we do all this. We configure, let's say, first of all, site-to-site VPN on the Windows, on the Cisco routers, and then on the firewall. So you can correlate, understand the concept better on the Palo Alto firewall. Right? Lot of theory concepts are there to understand the IPsec protocols. What is phase 1 negotiation, phase 2 negotiation, what happens in phase 1, what happens in phase 2, right? And what are these protocols all about? What is the port number? If at all port numbers, what's the port number for this? What's the port number for this? Do they give the packet directly to IP or UDP or TCP? Right? Like there are so many concepts. Cryptography basics. What is symmetric encryption? Asymmetric. What are these features? Only when you understand all this. IPsec is all about what? How to give security for the TCP/IP communication on the internet. Right? It's a very good concept we need to understand. This everybody has to learn. Any guy who's getting into security should definitely understand about what IPsec protocols. The best place to start is for Windows. Then on Cisco, because you're all familiar with working Cisco routers, right? If you know how to create the IKE policy, then IPsec policy, then you differentiate between phase 1 and phase 2, then you understand the concept better on Palo Alto firewall, right? Because most of us come from Cisco background, I thought I'll go like this further path to make you understand about IPsec protocols, right? Further again, you have this case study here. We have say head office here, we have say branch office, and how to do IPsec VPN between head office and branch office. One head office and one branch office. Again, one head office and two branch offices, right? Like that. So these two are right. And then we go for something called as remote access VPN, SSL VPN. We learn how to call SSL VPN, global product, the portal and gateway configuration. When these users are say working from home, when they want access the some services, some applications or file server here, they talk to the firewall. Authentication by the firewall local database. Authentic against the domain controller, right? Active Directory, and then how they get connected, right? So how to configure SSL VPN or remote access VPN we have in our case study. We really have one domain controller, we really have one file server, we really have all the users in the domain context here, right? We keep all this and then try to work on the case study. So these systems will be running in VMware, firewall and routers will be running in JNS3. So all these cases are pre-configured for you to do the labs. You don't have to worry about configuring all this, we have done everything for you. You just need to learn how to configure the firewall files. Then you learn how to do URL filtering, content ID, and also next generation firewall features like create a profile, attach profile to the security policy, check for virus, check for malware, all those things. And some miscellaneous topics also we add, right? So like that we developed a course on Palo Alto firewall. So theory class we learn the theory explanation along with the demonstration of case study, right? We learn theory concepts, also see the demonstration of the real life case study. Now, the most important point is what? How to do lab practice, right? If you don't do lab practice, then everything will go waste, right? So what we thought was, instead of asking you to do the lab on your own, we thought we make it as a group activity. It's working out very well because students are really doing the labs. Because when you try to work on so many cons at the same time, you may get stuck somewhere. So there should be somebody to help you out, right? So we have, let's say, group activity, lab activity. We have a data center. We have, let's say, servers in the data center. Around 40 servers are in the database. In the database, we are trying to buy more servers now. And we have, let's say, one administrator sitting over there. He will take care of giving the servers to you when you want to get connected. We have a server here, authentication server. So through internet, when students from their home, when students want to learn, you all can sit at your comfort of your home and then connect to the server here. You'll be given one username and password. When you supply username and password, a code will be sent to your Google Authenticator app. Once you authenticate using the code, you will get connected to your relevant server. And then all the users, all the students can get connected to the server, right? When they get connected, they can get connected to what? Their own servers like this, right? Then what happens? A lab faculty also is there. He will also get connected to same server. Now he can see what you are doing. So he can access all the server, all the connections he can see, and he can help. If at all the student says, I'm not able to configure, he can verify, he can go to this connection, verify what he's doing over there, and help him out in troubleshooting the concepts. So like that we thought we'll do proper group lab activity. And when you want to do the lab, you also can do the lab individually also if you want. So same thing, only thing is the lab faculty is not there to help you while doing the lab. You can get connected still, you can do the same way. But you need to talk to the administrator here to start the server for you so that you will be able to access it, right? So like that we developed a very good lab facility for students to practice on the case studies. What I showed to you, right? Those cases will be doing. And then for it help you, let's say, also do the lab practice, we have, let's say, we also post in a website solution videos. Say for example, this is the lab solution video for the Palo Alto firewall case study number 3. So in this particular case study, this is a lab solution. Like that we explain as to what you are going to learn. We also say go here, files. Go here, do this, click on files, go to server, click on then under home. So where what you need to do, where you need to do, what are you doing, how you need to do, right? We say pause the video for some and do the lab. Any problem is there, talk to the lab faculty, he'll solve the problem. Then again all of you do together. Like that, we also prepare the case study diagrams. We also prepare solution videos for you. 192.168. So like that we prepare solution videos also, post it online, we give access to the website There you can see recorded sessions or solution videos, and also take the quiz and self-assessments and then try to learn. You understand here? So about the trend, I see I am the train. I only does. I started teaching the courses from very long time. It was me those days, right? When I was in my, like, say, early 30s, right? So this was my first classroom, Sriram building in Chennai. I started somewhere in 1998, right? So we used to have very good lab setup that time. That time we used to get students only offline. So we had a lot of servers, lot of routers, around 700 routers were there. Systems were there. We used to give a network for the systems to do the labs. 3 routers, sometimes 5 routers, sometimes like say 5 systems and 3 routers. Different cases we used to give like this. And the students used to log on to the server, routers in the here, sitting here, they used to log on and then do the labs. And the faculty, lab faculty used to help. We are trying to get the same environment for online training now. So we also lab coordinators helping you out. See here, this part of lab code is helping the student do the labs, right? This was photographs from around 2000, 2004 and all. We had this photograph, right? So they get connected to the routers when they're working on the routers here. So this lab code is help them do the lab. Same thing we are trying to do online now. So you all get connected. Faculty also gets connected. So you can see what you are doing. Just click within seconds. You can go there. It can help you do the labs. I used to conduct a lot of workshops like this in different places. In Bangalore, I had a workshop on security. Those days we used to have, let's say, only real servers. We used to carry real, see the dias here now, the real server setup. I set up there and then show all the concepts of security for 2 days workshop and all. So like that we did a lot of workshops on security for railway officials, general manager of, let's say, railway, Southern Railways is there. So we used to do for Chartered Accountants of India. See the lab setup here now. Again, I put the lab setup and then configure and then show all the concepts, right? So whether I used to do workshops for a very long time. For different audience I did this. This actually used to, let's say, work the real routers those times. I wanted to do a workshop on routing protocols. So we carried around 32 routers, connected them in the rack over there. We showed the concepts of all routing protocols in around 1 day. Last time I did workshop, around 2000 people came for the workshop. I did the workshop in Chennai Trade Center in Chennai, where around 2000 people were there in the workshop. Right? So I would like to do again workshop. See, it's like Radia Perlman, right? You know Radia Perlman, she developed the STB protocol. She actually called as mother of internet also, right? So she came for Indian Security Conference SR Ministry Chennai. That time she was a chief guest for this workshop. And I conducted workshop there. For 2 days I did the workshop on security. She came also as a chief guest for this workshop. So like that, this is what I wanted to share with you as to how the Palo Alto firewall course is conducted. Right? We are starting a batch from Monday onwards. Coming Monday we are starting a batch from morning 7 o'clock to 9 o'clock a.m. 7 a.m. to 9 a.m. from Monday to Friday. If you are interested, you can join for the course. You can call Tanuja 809 58 22 right? Or you can send a WhatsApp message +91 right 809 52 and enroll for the course. Class will be from Monday to Friday. Theory and lab will go together. Theory concepts will be there, then lab also will be there. Then you do theory and do lab. See now recently I just uploaded one video in the YouTube channel. You can search for Koti Concepts YouTube channel. There I put a video over there. Yesterday night I posted this video.
Before doing this, because
about the lab practice video.
No,
You
can watch it. And then say what? Close.
Hereafter I will be posting lot of shorts and also a lot of, let's say, videos also online. So if you're interested, you can also watch the videos. You can subscribe and then get notification. Okay, ma'am. Any doubts you would like to ask, you can ask me before I close the session.
Is the batch only in for weekdays, not for weekend?
No, we'll be starting the batch in the weekend also now very soon. Interested, you can select. We have 3 slots. Morning 7 to 9, one slot is there. Night 7 to 9, again one more slot is there. Evening 7 to 9. Morning 7 to 9. Saturday, Sundays, again you have 2 slots. Morning 9 o'clock to 1 o'clock or 2 o'clock. Again 3 o'clock to 9 o'clock. We'll be having classes in 4 slots now. So, interested any slot, you can tell us. Then once we schedule the batch, we'll get back to you.
Okay, so interested for weekend one as working professional, that's why only. Okay, we'll drop a message to your mobile number, Tanuja.
Yes,
Okay,
yes, yes. Any more doubts?
Hi sir, Koti sir, good morning.
Good morning.
Sir,
Yes.
I have a doubt sir.
Yes, yes.
Hello sir.
Yes, Prashant. Yes, Prashant.
Sir, so this is a combo of Palo Alto
Right now, an offer is going on. Right now, an offer where we are teaching as a Palo Alto firewall along with the FortiGate firewall.
Okay.
FortiGate also we are giving as an add-on to this particular course right now. For this batch, we are giving FortiGate with Palo Alto.
Okay.
We'll finish up Palo Alto first of all, then we go for FortiGate. FortiGate also is same thing only. Same case studies will be there for FortiGate for also. We'll do case study based training only in FortiGate also.
Actually, yesterday we received this WhatsApp message with the Zoom link. In that it is mentioned like CCNA, Palo Alto and SD-WAN.
Yeah, we are starting actually one more batch for CCNA also. Right now, CCNA evening batch we are starting 7 to 9. Morning, let's say 7 to 9, Palo Alto firewall. Evening 7 to 9, CCNA we are teaching.
It's on separate batch.
Separate
Yes, sir.
batches. Separate batches. And very soon we thought we'll also start on SD-WAN prerequisite classes. To learn SD-WAN, right, you also need to have some prerequisite knowledge.
Yes.
You can't learn SD-WAN directly. So we thought we'll develop a small course on SD-WAN prerequisite course. Then we thought, why don't we make it as a proper course? Let's say. So if somebody wants to learn CCNP advanced routing, right, you also can join for the course. We thought we'll add all BGP concepts, also advanced routing concepts in the course, along with security concepts like IPsec, all tunnels, and all this, SSL, so that you'll be prepared to learn SD-WAN course later. Very soon we'll be launching SD-WAN also, maybe of 3-4 months from now. So for SD-WAN, to learn SD-WAN, you need to learn certain concepts that we thought we'll teach as a preparatory course for SD-WAN. That also is charging less, so 15,000 we are charging for that. We'll have a lot of concepts on BGP, MPLS, BGP, MPLS, and also voice routing protocol in depth. In other words, we'll be covering CCNP, advanced routing, along with security concepts like also NAT, also ACL, also high availability, right? To learn SD-WAN properly, what all is required that we thought we'll add in this particular course. I'll give proper, let's say, course content for that later. So right now I thought I'll only do for Palo Alto today. Slowly or I'll prepare a video and post on the YouTube channel. I think that's better, right? You can see at your leisure time and then decide you want to join for the course. Okay, ma'am? Any more doubts? Anybody would like to add something here? Normally I take, let's say, only technical sessions. First time I'm doing something like that, right? Okay. So we'll also come with technical sessions also. We thought we'll do some free classes on Saturdays, Sundays, right? Some call we'll take into. We'll also start, or I'll post it on YouTube also. I thought I'll be more active on YouTube hereafter. So please subscribe and keep checking. Okay, ma'am.
Hello, Koti sir.
Yes, Ajay Kumar.
Yeah, so are you planning for any persona-based trainings? Like, for example, in an enterprise setup, we'll have firewall engineering team, we'll have firewall SRE, firewall operations. So, what it takes for somebody, let's say, in the operations, and what it takes them to become an SRE or engineering. Because what we learn from these trainings is good, it's really good. We'll get the basic understanding, we'll know everything. But when it comes to working in a large companies, right, the setup and everything is different. Sometimes we may not have access. There is a lot of coordination that has to happen to get the things done. It will be really helpful for somebody if you can curate trainings specific to these roles like SRE, engineering, operations, things like that.
Good idea. So maybe you know my number, right? Please ping me on the number. Let's say I'll give the number to you now.
Yeah, I have your number. Yes.
Please call me now. We'll discuss about it. We'll see how to design the course. I'll also take the help from my friends who are in the real-time experience they have. I can also take their inputs and develop course as you said, right? So how to be prepared for the production. So far I was as you said, focus only on technical concepts only. So operations wise, what is required, how do we prepare? We'll see all that. Yes, I would like to be interested in doing this.
Okay, sir. Thank you.
Sir, hello.
Yes, ma'am. Yes, Dipana.
Sir, if possible, could you please conduct one workshop on tire architecture, 2 tires, 3 tires?
Okay, very soon I thought I'll also do offline workshops. Online workshops are good, but offline also I'll come to Chennai. Chennai is a center, right? So I accommodate those 60 students over there. We'll start doing on Saturdays, Sundays. I thought I'll do workshops also here. Yes. Okay, I'll stop the class now. We'll see again.